Welcome to Manufacturing 101, Session 1 by MPMA. I'm Steve Kalina, President and CEO of the Minnesota Precision Manufacturing Association, or MPMA, and I will be your instructor for today. I've got over 25 years of experience in the industry, from working in shops for over 20 years and then running the association for the last 7. The goal for today is really just to help you gain a little bit of confidence and basic understanding of manufacturing-related topics. After today, you'll be able to speak a little bit more of the language and feel more comfortable engaging with experienced coworkers or clients. Today, we'll be covering a few topics in Session 1 on general industry, machining, other manufacturing processes, and government and education. So there are a few ground rules for today's discussion. First, we're going to assume a level of no experience, so please don't be offended. I'm going to assume you know nothing about these topics. That way we start with the baseline and go from there. Second, there are no dumb questions. So I know this is a recording, so you're not going to be able to ask me questions today, but I encourage you to ask questions out at your facility or facilities that you're touring, and there are no dumb questions. So ask lots of questions, ask them about any topic, and just feel free to keep asking. Share on areas that you do know about. So we all have different levels of expertise, different areas of expertise you may take for granted and not realize that other people don't know some of the things that you know. So if you know certain areas, please share them with other coworkers, people that you know, and encourage them to explore and ask questions. And lastly, there are no perfect answers. So these answers today are meant to be basic explanations. It can vary by facility to facility, so or within the industry. So one term used in one shop may be used differently in another shop. I'm giving you kind of a baseline, generic answers to those questions, but you may find slightly different answers at different facilities. So we're going to jump right into some manufacturing vocabulary. First is a Lear ton. If you don't know what a Lear ton is, it's the way a foundry measures molten steel. Rule number 6, be careful who you trust with your questions. There is no such thing as a real Lear ton. It's just a different spelling for not real. So just a little icebreaker there, and a reminder that maybe you should verify who you're asking questions of. Diving right in, we're going to start with the topic of the general industry. One term you may be aware of is an OEM, or original equipment manufacturer. So those are companies that make their own product. They're the companies like 3M, Medtronic, John Deere, Ford, companies that are brand names that you know, products you use every day. They have their own product lines, and they use a supply chain of manufacturers, which we're going to talk about. So oftentimes these OEMs don't actually make all of their own products. They may make a certain portion of it. They may make the final product, the final assembly, package it, ship it out with their name on it. But as you will find out, there are many, many thousands of manufacturers out there that are supporting these big brands. As I just mentioned, OEMs don't make everything, and they rely on their supply chain. So the vast majority of manufacturers out there are actually at different tiers or levels within that supply chain supporting those OEMs. Those are what we call contract manufacturers. So contract manufacturers make product for someone else based on a contract. And when I say contract, it could be as simple as just a purchase order, which is a contract. Sometimes it could be a long-term agreement that spells out pricing and deliveries and all kinds of details that controls the relationship between the OEM and the contract manufacturer. And many contract manufacturers are at different levels, again, where they may not support the OEM directly. Some contract manufacturers provide components or services to other contract manufacturers, which then support the OEMs. So this is your general machine shops, welders, fabricators, plating companies, just about every manufacturer you can think of other than those OEMs that are supporting the OEMs. And again, this is the vast majority of manufacturers. These companies oftentimes do have production forecasts. They can do volumes of any type from single products up to millions of products. And then oftentimes have repeat work and can rely on forecasts and production orders and long-term agreements. On the other hand, one type of a contract manufacturer is what we call a job shop. You may have heard of that before. A job shop is a contract manufacturer. They do still work off of a contract, typically a purchase order, but typically more of a one-time purchase order or a short-term agreement, not the long-term agreements that we see with some contract manufacturers of higher volumes. So a contract manufacturer doesn't necessarily have a production schedule. They don't necessarily have a forecast. We call it a job shop because they kind of go job to job. So doesn't mean that they're not busy. Workload can ebb and flow. But those projects typically will be projects such as tooling, one-piece fabrication, prototyping. Again, they might be single projects, they might be single-piece projects, they might be several pieces, they might be several orders, but generally you don't have a long-term expectation or long-term plan. You may have long-term customers, but they come back kind of project by project. And then again, you can't really forecast that and know what to expect. The flip side of that, though, is that typically you will charge a greater premium for these parts. So oftentimes, most of the time, a prototype is going to cost a lot more than a high volume production part, simply because there's a lot more engineering and time and less efficiency involved up front. So here's an example just of a tooling, different fixturing that can hold things in place during a manufacturing process. This is not something you would mass produce, but it takes a lot of hours and a lot of planning into building something like this for a one-piece production run. What you read about in magazines and watch on the evening news these days is often the cool new technologies that are used in industry and, of course, in daily lives now. So what we call this in manufacturing is Industry 4.0, also known as the Fourth Industrial Revolution. So this is all the cool new technologies that, we use automation and cool equipment that we're using to make stuff, but it's all the stuff that's kind of the new, latest and greatest innovations on how we're using digital technologies in the workplace. So this includes the Internet of Things, AI, SPC, and automation. So Internet of Things is really just the proliferation of internet in our workplace, right? So years ago, machines were run manually. They were controlled manually at the point of use. Now, most machines in shops are controlled with a program, but also connected electronically, connected wirelessly to the company's network. So through the internet, you're controlling machines, you're updating machines, you're monitoring machines. People could be working from home and monitoring the data on their machines. So the internet is just obviously a lot more common thread in the workplace than it was 30 years ago, not just for emails and for looking up websites, but for running the shop and for sharing data within the shop. And of course, AI has been being used daily in most people's lives now, using ChatGPT and using Google to look up AI information. So AI is an integral part of the workplace now. It's not quite as in depth as say the internet and other technologies, but companies are starting to use it much more on intuitive programming of machines, and obviously for different office uses and whatnot. So it's not quite as embedded in industry and in the shop yet, but obviously that is coming fast and furious. SPC stands for Statistical Process Control. So that's really just monitoring, measuring, and using that information to control machines or control processes on the shop floor. So more and more equipment now are using in-process inspections at the point of use, and then that data can be used to adjust the process. So a machine can actually automatically adapt a process and changes in that process to what it's finding in the actual product inspections. And of course, automation has been there for many, many years, whether you're just picturing a robot that's producing product, or different features within the machines where automation can be different work holding devices, like I said, inspection processes, and movement of product, autonomous vehicles on the shop floor and the warehouse. So automation, whereas it used to have its purpose for more high volume production, is now used in almost every shop in some form or fashion. So companies that perhaps are doing small volume, I mentioned job shops, would have historically not invested in automation, and now those shops have to, primarily because they don't have the labor to run things manually, and they need that level of efficiency and just to be able to produce things, need to automate as much as possible. So a lot of this is just, we refer to as data-driven systems, data that helps us manage our shops, helps understand what our machines are doing, what the product's doing, and how to make those improvements. I'm going to share with you just a few more options on where to find information, just kind of on general industry activities and technologies. So one is by going to different trade shows. So a couple that I'll mention are IMTS, the International Manufacturing and Technology Show. It's in Chicago every 2 years, and then FabTech. So these are a couple of big shows, huge shows that draw people from around the world. MPMA actually coordinates a trip to IMTS every 2 years, where we bring about 85 to 90 manufacturers from Minnesota together on a flight and stay in the same hotel. And there's lots of other shows like these, but these are a couple real key ones for the industry where you can go explore, see different pieces of equipment, do new technologies, ask lots of questions. So just a great way to kind of explore and not have any kind of obligation or somebody hounding you for trying to sell you on anything. You can just go and explore and learn a lot. Another one is local open houses. So manufacturing companies or distributors who are doing open houses to just share information or new technologies that they sell. A couple that are coming up in Minnesota that are kind of on alternating years from IMTS, but Oktoberfest with Productivity is one, Steakfest with Concept. Many other distributors have events just like these. So if you go to mpma.com/events, we list those kind of events, member events, community events, but they're happening on a regular basis. So you can stay tuned to mpma.com to find out about those, but otherwise you can go to any probably distributor and find out when and what they have for open house events. Lastly, I'll put on here for more advanced learning. So this is maybe more in depth than many of you may want, but there may be some aspect of something that you want to just dig in a little bit more. So one great resource is called the Titans of CNC. So Titan Gilroy was a young man who was a professional boxer, got in a fight he shouldn't have, and ended up going to prison for quite a few years. And while he was in prison, started developing skills as a machinist, got out, started his own company, was very successful, and then actually started a TV show, and along the way started what he called Titans of CNC Academy. So it's free training. He developed it just to be able to share, especially with young people that are getting involved in the industry, to learn and grow. And so it's you have to sign up to receive it, but otherwise you can go in and just start pulling up videos and programs and learn all kinds of stuff. So if you want to learn how to square up blocks in a mill, if you want to learn how to use inspection equipment, if you want to learn how to do actual CNC programming. So some of that gets way beyond maybe where you're at, but there are some simple applications where you can learn just some basics and at least get started and then decide where you go from there. So I'd encourage you to look into that.
For the next topic, we're going to dive a little bit deeper into specifically machining technologies. You've probably heard the term additive manufacturing, which we'll talk about in just a minute, but what you may not have heard is the term subtractive manufacturing, and that's really just the process of removing something. So in this case, we're going to take a block of steel, just a simple rectangular block, and then we're going to take away material by some kind of a manufacturing process, in this case machining, and in this picture actually an aluminum block. But basically we're removing material by using, in this case, a cutter, which we'll talk about a few different operations of manufacturing, but you're taking an initial block, removing materials to get to a final product. In this case, we'll refer to it as a widget. So we're going to talk about a few different typical machining processes that you've probably heard or seen different operations. We're going to start by talking about milling. Milling is basically, if you imagine a handheld drill, you've got a drill bit that's spinning and cutting away, cutting a hole. In this case, you've got a machine doing it, so you've got a machine that has what looks kind of like a drill bit, and it's spinning and cutting away material. So this is what you often see in machine shops, milling, CNC milling. In this case, it's a CNC, so it's a computer controlled, which we'll talk about in a bit as well. Other shops or other areas of a shop, you might see a more manual machine, so it's much smaller, many less electronics and gadgets hanging off of it. So again, you'll see many different versions of machines like this, so it's hard to necessarily pinpoint exactly what they are and what they do. But in general, what you're going to see is that they're doing subtractive manufacturing. They're taking away materials inside of that machine. As you can see here, as we saw in the last slide too, you're cutting away material. Like I said, kind of looks like a drill bit. It's just taking away bits of material little by little. There's all kinds of different cutters and bits and tooling that you'll see that takes away the material in different ways, whether on the side of the cutter or the face of the cutter. Again, you don't need to necessarily worry about all those details, but just understand that most of those machines are taking away materials. Another type of common manufacturing process then is turning, which is similar to milling. Milling, like you just saw, was the drill bit, the cutter coming in vertically and cutting into material. It can also be coming in horizontally, but the bit itself is spinning. It's rotating. The product is generally staying still, although it can move at different angles to kind of get different geometries and different approaches. Turning, on the other hand, which you've maybe heard the terms lathe or Swiss, those are different types of turning operations, that you're actually spinning the product. So the material, which we often refer to as bar stock, just a rod, a cylindrical rod of material, spins while the cutter is actually staying stationary. So what you see in this picture here is a lathe. It's hard to see all the details, but you can see on the left-hand side there's what would hold the raw material. So the raw material would actually be fed from the left side of this machine in what we often call a bar stock feeder. So you'll often see those hanging off the end of the machine. The bar stock will be fed into the machine, and then that'll be spinning as the cutting tool just stays stationary. So here you can see the cutting tool. In this case, this cylinder of material will be spinning at a high rate of speed, and the cutter is taking away material little by little. So this is often an application for threaded components, real high, tight tolerance, really small, intricate, detailed parts. So that's when referred to as Swiss, is really more complicated, tight tolerance, threaded components typically. Now that we've talked about more of the front-facing activities of manufacturing, the things that you see and touch and feel and machines that are operating, we're going to talk about more of the front end, the things that you don't necessarily see. So we'll kind of go through the phase of a project from start to finish, or until it gets onto the shop floor. So what you're going to start with is kind of the design of a product. So you've maybe heard the term CAD before. What that stands for is computer-aided design, and some examples would be examples of the software would be Autodesk, SolidWorks, Pro-E. And so what you have is a designer sitting down and designing the actual product. So this is typically done by the OEM, the original equipment manufacturer, because they own the product. It's their product. They've got design engineers, product engineers, marketing people, all the people that go into deciding what a product's going to look like and how it's going to operate. And so the designer, the CAD designer, is going to sit down and figure out what exactly the product looks like, the shape, the size, the features, the geometries, and just piecing it all together. And in this case, you might have dozens of components that go into an assembly, and so they're figuring out how those are all going to interact, how they're going to fit together. So it's very critical to make sure this is done right prior to manufacturing. What you'll often see is that a designer may not necessarily know the manufacturing processes, and so they may create a model of a product, and it may look great, it may theoretically work well, but then a manufacturer would come along and say, well, you can't manufacture it that way. There's no way to actually produce it that way, or it's horribly inefficient that way. So again, I mentioned this is kind of a sequence of activities from start to finish. It's ever evolving. There's not typically many programs that would go to start to finish and just sequentially and from person to person without any interaction. So oftentimes that CAD designer is going to hand off that model, that design, to a CAM person, a CAM programmer. So CAM stands for Computer Aided Manufacturing or Computer Aided Machining. Some software examples would be Mastercam, GibbsCam. So this person is going to take that model, that design that comes from the CAD designer, and they're going to figure out how to manufacture it. I mentioned, just because you make a product on paper, design it, doesn't necessarily mean that it's manufacturable. So the CAM person, the CAM programmer, is going to figure out what machine to use. In this case, you can look at the picture. It shows those blue lines are basically a cutting tool path. So they're deciding how that product's going to be cut, what geometries or what tooling to use, what machine to use, the speed, the radii that are going to be designed in. So they're going to figure out how to make that product the best way possible, the most efficient possible, the best quality possible. And in some cases have to go back to the CAD designer to say, well, you can't manufacture it this way, so can you modify your design so that we can make it more manufacturable? So this person is actually writing the code or the program that's going to be used in the machine to tell the machine what to do. So they're kind of writing the program for the machine. And which leads to the next one, CNC, that I'm sure you've probably heard of. That stands for Computer Numerically Controlled. So that basically is just a fancy way of saying a machine that has some kind of a computerized system. So I mentioned earlier, you will have manual machines that don't have all the computers attached to it, but most of the manufacturing done today is done in CNC machines. So again, they're computer controlled. So somebody's writing a program for it, uploading that program into the machine somehow, and then the machine is run based on what that programmer told it to do. So again, the machine operator, and you'll find that every company has varying levels of machine operators. Sometimes they will be more push button oriented, where they're just taking a program that exists, they're loading and unloading the product, and push and go, push and go, push and go. Today we see more and more CNC machinists that are more trained to actually modify the program if they notice that the machine's not running quite the way they want. If there's too much chatter or the surface finish isn't the way they want, they can adjust that program at the machining center to get it fine-tuned. And the third topic we're diving into is other manufacturing processes. There are dozens upon dozens of different manufacturing processes within manufacturing, so you will never learn them all, and I wouldn't worry about that. The few that we're going over today are kind of some of the basic ones, and in many cases, when you're in shops and you see machines you don't recognize, they may be just slight deviations from the manufacturing processes you already do know. So that's a great opportunity to ask questions and find out how those machines and operations might be slightly different. But again, if you learn the basics, you'll have a pretty good understanding of what that machine is there to do. So the first one we're going to talk about is tool and die. And that's one of the more complicated, more highly skilled manufacturing processes. So what we talked about in machining is a product, an end product. You're not necessarily mass producing, but it's an end product, so it may be thousands or millions of parts you're making. On the tool and die side, it's usually one-off or just a several of something. So some examples are injection molds, die casting, fixtures, and those are manufactured products that are used to make something else. So a fixture, you're not going to necessarily sell a fixture in a store. Typically that's used to hold a piece of material that's going to be manufactured into some other final product. An injection mold is not a sellable product to the public, at least, but it is used to make other products. Same thing with die casting. So here's a quick example of an injection mold. So this is not, again, a sellable product. This is going to be used by one manufacturer, produced by another manufacturer typically. And so in this case, it's going to be used to make 4 parts of something. And so it's got a cavity cut into it that's the geometry of the product. And so you're going to take a process like injection molding, which I'll talk about in a minute, put plastic into this to form the shape of the product. And there's all kinds of other moving components in this injection mold, and then it'll spit out a product. So again, this isn't a product you'd see on a shelf anywhere, but manufacturers use these every day and make products that you're familiar with every day, which I will talk about now through injection molding. So injection molding, that process would be taking that mold that we just showed and using it to make a final product. So you can watch this video here. This is an injection molding machine. It's taking raw plastic material, pellets, putting it through a barrel that's heated, with a screw in it that pushes the material forward, and then it's pushing it into this injection mold. You can see right in front of you. That's actually heated and cooled simultaneously. So the molten plastic goes into it, and forms the shapes of the parts, and then spits the parts out. So again, there's lots of other moving components and things going on in there, but that is a process, again, you may not have seen in shops, but injection molding is a process that's used to make parts that you touch and work with every day. Parts that go into your cell phone, parts that go into your computer, parts that are in your car are oftentimes injection molded. In fact, metal injection molding is actually more and more common now. So typically parts that are used in firearms or dental braces, things that are very intricate, detailed, but maybe higher volume, can actually be produced using metal injection molding, which I won't go into details today, but it's an interesting process. Next process we're going to talk about is EDM, or electro-discharge machining. 2 examples of that are wire and sinker EDM. So we're going to talk about the sinker EDM first. So what this does is take a carbon electrode, they call it. It's just a piece of carbon material that has geometry cut into it, and they're going to mount that into the machine. And then there's a fluid that's called a dielectric fluid that is used to convey the electric charge. The electricity goes from the carbon electrode through the fluid and then into your steel block. So this is often going to be used for parts that have geometries that can't be machined. Today, machining centers are much more capable and can hold tolerances and perform geometries that couldn't in years past. So EDM is maybe a little less common than it was 10, 15, 20 years ago. But oftentimes it's, again, details that you just can't machine out. And so this allows you to basically eat away the steel little by little. So you're taking away microns at a time. So oftentimes EDM processes will take hours, if not most of a day, just to take out some small amount of geometry because it's doing it so small amounts at a time and very intricately. Another process then is the wire EDM. So this is very similar to the sinker EDM, but instead of using a carbon electrode, it's using a wire. So the wire actually is fed and cycles through the machine and is using that same electric current to spark the steel that you're removing. And so this is often used for really intricate external geometries, perimeters around a part, where you need to cut it very finely and very precisely. The next thing we'll talk about is grinding, which in concept is very simple, but oftentimes the grinding we see done in manufacturers is very high precision and very complex. So this picture just shows a grinding wheel that's grinding away, some level or layer of steel off of these cylinders. So oftentimes it's to get kind of a first pass at getting a block of steel to be closer in geometry to what you need, or taking off a small surface amount of material. But oftentimes grinding will be used for very highly intricate processes that maybe you need to take away microns to get down to the size that you need. So grinding is actually a very skilled and very fine-tuned process, as simple as the concept is. Next is fabrication. So these are oftentimes the operations you hear of as stamping, bending, laser cutting. So it's what we've talked about so far has been mostly subtractive manufacturing, where you're taking material away to make a final product. Fabrication is modifying that product. So in many cases, you're talking about sheet metal applications, where you're taking a piece of sheet metal and modifying it in some way. So in this case, in this picture, it's a stamping process or a forming process where you can see those holes in the part. Those have been stamped out. So those are using a die that we talked about a little bit ago that would be used to remove the metal by punching into it. And in this case, what you see here is a forming process where it's punching into the part to shape it. So as you can see, there's the two sidewalls that have already been shaped. That's very common in manufacturing, especially on like housings for maybe computer towers or electrical boxes where you need different cords coming in and out, or airflow, and so you have all kinds of different modifications you're making to the material before you assemble the final product. And next we're going to talk about the favorite manufacturing process of many middle schooler and high schoolers, which is additive manufacturing. So you may have heard that term and maybe didn't necessarily know what it meant, but it's basically building a 3D object layer by layer. So subtractive manufacturing is taking a block of steel, plastic, or otherwise, and removing material to get to the final product. Additive is starting from scratch, starting from nothing, and producing something. So in general, it's 3D printing. Again, there are many different types of 3D printing, which I won't go into today, but in general, you're starting from nothing and you're layer by layer by layer adding little bits of material to create a product from scratch. In many cases, there's products that can't be manufactured through subtractive manufacturing that need to be done additively. In other cases, it's just easier to do additive. So you can take a design and just make it up using a 3D printer, many times used for prototyping and first off products, low volume products. Not necessarily the precision, although the technology has expanded and improved greatly over the past years. So 3D printing is very capable these days, but still some applications where it can't hold the tolerances and it can't produce as fast as other manufacturing processes. So it has its niche uses, but those uses are expanding daily, and just really cool and has really innovated the way shops operate nowadays, where in the past, if you needed a prototype, you made it put in a purchase order with another shop down the street, and it took 2-3 weeks to get. Now you might have a prototype in a matter of hours, and it gives shops much more flexibility to design and develop new products. The last topic we're going to talk about today is government and education, which maybe seems like an odd topic for beginner manufacturers or people that are new to the industry, but workforce is one of the most important topics of every manufacturer these days. We need more people, more skilled people, need to develop the people we've got. And so oftentimes people new to the industry are either the new person coming into a skilled trade, or it may be an HR person that needs to understand what some of the government and training programs are available out there. And so it's important for us to understand what resources there are and be able to share those resources. I mentioned earlier that everyone has their different definitions of different words and examples, and so again, I'm going to share my experience and my definition of a couple of these words, but I'll say in general it represents most of what's happening within the industry. So we're going to talk about internship, which you've probably heard that term, oftentimes refers to high school programs. It's typically more of an exposure-focused program, so it might be 1 week, it might be 1 year. It's about learning, it's about education. It's not necessarily building up a skill of someone that's going to just suddenly be ready to take on a job and be a skilled tradesperson. It's just about exploring and kind of career exploration and understanding if it's something you have interest in. So again, it's oftentimes used for high schoolers. They could be summer internships. It could be more of a organized program in a community where they're going to do a week-long internship or in multiple facilities. Or it might be an employer who brings in interns officially and brings them in for the better part of a year and then decides whether they're going to move on to an apprenticeship program or get hired. The next word is apprenticeship, which it's a big keyword in the training and development and workforce development industry today. Apprenticeship is going to be a little bit more in depth, and so this is actually where you're developing the skill of a person. So it involves the actual training and mentorship. Oftentimes apprenticeships are 6 months to several years where you're actually learning the skilled trade. So again, the internship is more about the exposure. The apprenticeship is more about the actual skill building. And so again, you may take somebody fresh out of high school or their first job in the trade, and they may do an internship just to kind of figure out if they like it, and then you move them into an apprenticeship, which in general in manufacturing apprenticeships are paid, and they'll be going to school, doing on-the-job training, learning and building their skills and getting paid, so it is a job, but then developing into that full-time machinist or welder or otherwise. The resources, and I will say Minnesota has a lot of great resources for workforce development. So what we refer to affectionately as DOLI in Minnesota is the Department of Labor and Industry. And this is oftentimes intended to protect the workforce, support the workforce. So Department of Labor is what oversees the unemployment and kind of employee rights and whatnot. But they also have programs around workforce development and developing those people. DEED is the Department of Employment and Economic Development. So this is a little bit more focused on business and developing and growing businesses, oftentimes through employees. So there are many great workforce programs through DEED in Minnesota, but it's a little bit more focused on the employer and helping those employers grow. So you'll also find DEED as a resource if you were going to build a new facility in a community. DEED can help you find different economic support resources and financial incentives through that community. The Office of Higher Ed, OHE, is what oversees the higher education in Minnesota, so the post-secondary schools, which includes the Minnesota State College system. So all of the technical colleges, the state colleges in Minnesota fall under the OHE. And so oftentimes, again, MPMA is highly partnered with especially the tech schools, but the schools that fall under OHE. And OHE is also involved in some of the workforce training programs. And last on here is the MDE, or Minnesota Department of Education, which is more the K-12 focus. So again, that's for our sake, we're typically dealing with the tech ed programs in the high schools and internships and some of the other programs that MDE offers. I'll take a little deeper dive into some of the programs that those state agencies provide. First, I'll talk about is the Dual Training Grant, formerly called Pipeline, that is managed by the Department of Labor and Industry, but financially overseen by the Office of Higher Ed. And so, as the name implies, the Dual Training Grant is a two-pronged approach, where students, in this case, they have to be employees. And so oftentimes it's an employee that is at an entry level or at a early level in their career where they may be working in the warehouse or an assembly line, and they want to become more of a skilled tradesperson. And so the state sponsors up to $6,000 a year for training, and so this has to be at an accredited educational institution. So oftentimes for us, it's usually a technical college, sometimes a university, but it has to be an educational institution that's providing some kind of an outcome, a 4-year degree, a 2-year degree, a certificate, some kind of a industry recognized credential. And so the intent has to be that the student or the employee is working towards that. And again, it can supply up to $6,000 a year and a $24,000 lifetime, which they are talking about increasing. What it used to be was $6,000 per year up to 4 years for a total of $24,000. But what we often found is that many of these students are working adults who can't go to school full time, and so they may just take 2 or 3 classes in a given year and only spend $2,000, which meant in the past they would lose $6,000 of eligibility. And the state did change that, so now it's indefinite. So it's up to $6,000 a year, up to $24,000, but you can use it as many years as you need to. So if you go to school for, again, a couple classes and spend $1,000 or $2,000, you can keep using it and keep accumulating over time. And on the flip side, then you've got the employer side. I mentioned it's a two-pronged approach. So in addition to the schooling, the more formal education, the employer is required to do an apprenticeship model training. So it requires mentorship. It requires a scheduled, planned approach to training. And so, again, I mentioned apprenticeship is a general term. It can be kind of customized and different for each employer, but they have to show that they're indeed training that person. The person may be working full-time in a production job and producing production parts, and that's fine, but they have to have training as an element of their weekly schedule at the employer. And so typically having a mentor and then someone probably from HR or management that's overseeing it. MPMA for the last few years has actually created a cohort of a grant application. So we actually apply for the grant on behalf of dozens of manufacturers and dozens of employees. And so we apply for the grant, manage the grant, and then help employers take advantage of it. So that's been a great model that's worked really well. So if you want to learn more about that, definitely reach out to MPMA. The MJSP grant, which stands for the Minnesota Job Skills Partnership, which is put out by DEED, Department of Employment and Economic Development. MJSP is a little bit more of a customized approach. So it's more focused on the employer and what specific skills they need. And so oftentimes it's company-wide training or a group of people within a company that are going to do training, oftentimes customized training. So it's a little bit more flexible in what the outcomes are and what the specific skill sets are versus the dual training grant that's a little bit more focused on degreed and certificate programs. YST is a program that MPMA has been excited to help champion. We actually helped champion the legislation many years ago. It stands for Youth Skills Training. It's managed by the Department of Labor and Industry. But this is along the lines of more the internship. So this is for 16 and 17-year-olds, which traditionally could not have done much in a manufacturing facility. They'd be restricted to, pushing a broom or a glorified tour or just kind of getting exposure to things. We knew that as an industry that wasn't good enough to get someone to a higher skill level and get them ready for a career. And so youth skills training allows those 16 and 17-year-olds to actually do hands-on training in production. So they can actually do machining, do welding. There are certain restrictions. It's managed through the school, so the school has oversight to make sure that the students are being taken care of and that everything's safe. Department of Labor also has staff that does verification checks on those employers to make sure it's a safe workplace for a student to work. But it's a great opportunity for younger people who may get to watch TV and see what it's like to be a doctor, lawyer, police officer, but don't know anything about manufacturing. And this gives them the chance to not just tour a manufacturing facility, but actually learn some of the trade before they make a commitment to go to a technical college or start their career path. Today it may have felt like we learned a lot, but I can tell you it was just the tip of the iceberg, and learning about manufacturing is a never-ending, lifelong process. And with that, I want to give you a quick preview of the next session. It's amazing for what we covered today. We didn't even touch on several topics. And so the session 2 preview here, which will come out in the next few months, we are going to cover equipment and materials. So today we talked about more manufacturing processes and applications. Next time we'll talk a little bit more about the specific equipment and how those raw materials are converted. We're going to talk about quality. So after a product's made, of course, it needs to be verified and make sure it meets certain specifications, and there's all kinds of cool technology around that. Lean is common to workplaces in manufacturing these days. It's about basically just making sure we've got an efficient process, limiting waste in resources and materials, making sure that we're all on the same page. And so we'll talk about that. And then other shop talk. So just some of the other terminology you'll find in the workshops. ERP kind of refers to the whole back-end database that kind of manages the operations of the shop. Cycle times, work cells, all kinds of shop talk. With that, of course, I would love to hear your questions. I know it's a recorded session today, but feel free to reach out if you've got any questions on anything I covered today or anything I didn't cover or requests for future topics. And of course, as I mentioned, please go out into your shop or shops you're touring and ask lots of questions. Again, there are no dumb questions. Just keep learning, asking, observing, and people will love to share with you all kinds of cool new things. I want to thank you for joining me and MPMA today for Manufacturing 101. And I look forward to seeing you soon and hopefully at Manufacturing 102.